A very good afternoon, everyone. So as always, this is my name is Umi Nishar Banu. I'm a consultant trainer in Sankyana Consultancy Services. So let's start with our today's webinar session. So we are going to talk about our today's webinar topic, that is what are some of the statistical concepts that will help you on your journey as a data scientist or data analyst. So we just getting to know like what will be few of the concepts which is very important. So some people eagerly wanted to go and become a data scientist or a data analyst. So we are just going to see like how important statistics is and what are the main important concepts you should know as a data scientist or data analyst. So yeah, I can see many comments also there. Hi everyone. And when it comes to data science, it's a like multi-faceted and interdisciplinary field of study, right? So it's not just dominating the digital world. So it's integral to some of the most basic functions, like we have the internet searches outside, we have social media feeds, political campaigns, grocery store stockings, airline routes. So I can list out these many things like hospital appointments and many more. So it's like everywhere. So what makes this data science so applicable to human experiences, we can say? And like among the other disciplines, statistics is one of the most important discipline for the data scientist. So when we say data science is a multidisciplinary field, and among all the multidisciplinary, one of it is statistics, which is very important. So in data science, the statistics is at the core of sophisticated machine learning algorithms, like capturing and translating the data patterns into like actionable evidences. Like data scientists use the statistics to gather, review or analyze and draw conclusion from the data. So this is what we are going to learn from it. We are going to see like in detail of the important statistical concepts also. So the agenda of today's session, which we are going to talk about, is what is data science and importance of statistics for data science, and the statistical concepts which is required is the data distribution, what is central limit theorem, correlation versus causation, central tendency and dispersion, p-values. So these are all the these are all the topics which we are going to discuss, which is coming under the statistics, which is very important for a data analyst and a data scientist. So we are it's just a 30 minute session, so I'm just going to give a brief about each and every concept. So let's start with data science. So you all know like exactly when I ask you all exactly what is data science. So data science, if it is like we say, it is a field of study that will utilize the cutting edge tools and techniques so that it can uncover any kind of hidden patterns and trends in the data. And trends in the data, like thereby we will be able to generate the valuable insights that can be used for a proper business decision. Our main concept here is we should end up with a good decision, right? With the tables with the data which we are having, we should have a useful decision in our hand. So we will be able to get more informed decision with the help of the data. So it also encompasses the predictive analytics in which the data scientists employ a variety of machine learning and statistical algorithms out there. Algorithms out there. So it is very important whenever we talk about the data science, right? It is very important for us to know about the data science life cycle. So when it comes to a data science life cycle, to like whenever I want to comprehend or whenever I want to know about the role of a statistics, what it is going to play in a data science. Okay, what it is going to play in a data science, like you must first have a thorough understanding of what is the data science life cycle. So only if you try to understand what is a data science life cycle, so there are several perspectives on the life cycle. So but like the simplified one, as you can see here, are the 5 stages. Like we have the capture, we have maintain, we have process the data, analyze the data, and we can communicate the data here. So if you see here, capture the data, which is nothing but I can structure our unstructured data will be the raw data are gathered. So this stage involves the data acquisition, entry, and extraction. And the next one is maintain. So when I have a raw data in our hand, I can is made usable. I'm going to make it relevant data. So this stage maintains the data through the data warehousing, cleansing, staging, etc., and then processing of the data. So after you capture the data and you maintain the data, then you process the data to examine and produce the data for the patterns, ranges, and the biases to determine its predictive value. So using a data mining, modeling, summarization, etc. And then we have analysis. After I process the data, I go for analysis, like using regression, qualitative analysis, predictive analysis, and to analyze my data. Once I analyze my data, I communicate. So I will have to tell the vendor or a client that this is what I have got from the data which you have provided. So the analyst will write the data in an easy to read and an understandable format, so that with the help of the graphs, charts, and the reports, he will be sending the reports and communicating the data. So there are other data science life cycles, like for example we say it as a like OSEMN, which is nothing but it stands to obtain, scrub the data, explore the data, model the data, and interpret the data, which will represent the 5-phase life cycle even there also. So this is what a data science. Now coming to the importance of the statistics for data science. So what are the importance for statistics of the data science? When I ask the importance, when it comes to statistics, like statistics is like, it is a broadest sense. When we talk about statistics, it is one of the broadest sense, which refers to the collection of what all the tools and the methods are there, so that I can evaluate the data, and interpret the data, displaying and making the decisions based on the data. So some individuals refer to statistics as a mathematical analysis of the technical data. So with this way also they try to analyze the data. So when it comes to the importance, so we can utilize the statistical analysis techniques to quantify what we have, so that instead of swifting through the a large or a huge amount of data, we can describe it using a few metrics. Okay, and with the help of the statistics, I have a large amount of data. Let's say I have millions of data or trillions of data. I want to when I apply the statistics, it should be in a proper quantifiable way, right? So I can utilize the statistical analysis technique to quantify what we have, so that so instead of using that voluminous of the data, we can describe it with the few metrics. So like for example, we have advanced machine learning algorithms in the data science. So that machine learning in the data science, it uses this statistics, so that it can identify and it can convert the data patterns in a very usable evidence. Okay, very usable evidence. Like data scientists use the statistics to collect the data, to evaluate the data. He can analyze the data and draw conclusions from the data, as well as implement a quantitative mathematical models. We say it as a quantitative. So what is quantitative? It is a like measurable one. So quantitative mathematical models for the like the variables which is there in that data. So data science requires both technical skills, like for example, we have the different programming languages. We have R programming language, we have Python programming language. So when it comes to a data science, it is very important that particular person should have a knowledge and a technical skill like R or a Python programming language, and he should also have the other skills like soft skills such as communications and attention to the details should be there. That also should be considered. So I can say like most important skill a data scientist must have, so that he can enhance his statistical abilities, is like he should know statistics. So when it comes to statistics, so the data scientist should make an effort to learn the statistics, because the statistics will relate the data to the questions like organizations face across all the disciplines. Okay, it's, we are like when it comes to data science, it's not only sticking to one particular domain. We have multi domains which is using the data science, right? So we have how to increase the revenue, such as I want to know how to increase the revenue, how to limit the spending, how to create the efficiencies, and how to maximize the communication. So these are all the disciplines where I can apply the data science and the statistics as. So that is one of the first part. Like statistics is the ability which a data scientist must possess. And other than the data scientist, we also have data manipulation. He should know what is data manipulation, like using Excel or SAS or stat like Power Query, like Spark, any kind of data analysis, like data manipulation, he should know using the programming languages, so that the data scientist can clean and organize the large data set. So that they say kind of a product, I always say this, we have a data in like a garbage in garbage out, we say it as. So what is the meaning of that? Like whenever I give a like a dirty data into the machine to learn from the data, and you predict a new value for us, what will happen if the dirty data is given? I will be getting a answer which is irrelevant. So whenever I give a data to a machine to get it trained or create a model, I should give a complete or a proper model which is cleaned data, which will be using a clean data. So with the help of the data manipulation, only a person can be able to organize and clean the data sets. Let the data set be small or a large data set, he should know the data manipulation techniques. And then we should also have that data scientist should also possess critical thinking. So when I talk about critical thinking, so a data scientist will identify and he will model the relationship between the dependent and the independent variables, which variable is dependent on the another variable, which variable is not dependent, which is acting independently, like using linear regressions I can judge. That is a machine learning algorithm. So data scientists should choose the procedures with underlying assumptions that are considered during the implementation. So if an assumptions are violated or incorrectly selected, so the results also will be incorrect. So we will have to keep a proper assumptions what we are, the hypothesis should be always correct. And then organization. So along with the statistics, data manipulation, critical thinking, data scientist, important skill what a data scientist should have is organization. So a data scientist, they are like a constantly involved with the data from a variety of sources and the project opportunities which is getting outside. So expertise in this statistical functions will enable the data scientists to work effectively within the budget and the time constraints which has been given to them. So the routine process also contribute to the data security protections which is also coming there. Along with the organization, he should also have the capability of problem solving. So everybody should possess this particular skill, that is problem solving. So in addition to the pure computations and fundamental data and data analysis, a data scientist will use the applied statistics to relate the discoveries to the real world problems. So additionally, the data scientist utilizes like predictive analytics, so that to plan the future action, what he can do in the future, so that when I get to know what will happen in my data, I can predict the data, I can go and try to plan my future. Okay, I go with this plan and I will succeed. So all of this necessities is like a careful consideration should be done, as well as a rational and an innovative problem solving strategies should be possessed by that particular person, or a data analyst, or a upcoming a data scientist. So these are all the skills which you should know, or which you should have as a data scientist or a data analyst. So I guess that this will be enough of talking about us main skills and the things what a data scientist should possess in the field of statistics. Now let me just go with the first part, the important concepts which concepts for a data scientist, statistical concepts which a data scientist should know, like, or what are the some statistical concepts that will help you on the journey as a data scientist or a data analyst. So like statistics, as we all came to know that statistics is one of the major component of the data scientist job description. Okay, like knowing the statistics is especially very important when it comes to making conclusions like about the data or the models, like avoiding common pitfalls that we can fall into when building the models or analysis, and there might be temptations to discard the statistics in a world where the computing power and the artificial intelligence innovation is there, which is very getting boosted every single day. So why learn about the p values, data distribution, or correlation versus the causality, like when one can build a simple fit model with the powerful AI or machine learning. Okay, so these are all there, but then why then we should learn these kind of data distributions and others. So there are like three arguments that can provide a view on the discarding like the statistics, which people try to neglect more. Like most problems are not solved using the state of art like artificial intelligence, and most organizations, they are not ready to retrain the models every single day. And when it comes to statistics, it is a science that will study the studies, and it generalizes the ability to make the estimations and the assumptions about the data that you don't have. Okay, now that is what it is required, right? What is not there with us, that is what we are going to find out from there, so which is not required. So like we are going to learn a few of the a few of the statistical concepts, starting from our data distribution. So most of the variables follow the specific data distribution. When it comes to like most of the variables will follow the specific data distributions. Like you have probably might have seen the random variables that look like the following plotted table, which is there in the figure. So this is a random like a random normal distribution which is generated. So a density plot of normal random distribution. When it comes to a normal distribution, you will get a bell shaped curve. So this is a famous, we call this as a famous bell shaped curve that represents the normal distribution, which means you have cleaned the data, and when you are plotting a graph like this, you should get a bell shaped curve, which means your data is been normally distributed. Okay, normal distributed. So but there are like other such of the log normal distributions also. We also use the other like a log normal distribution, which you should know when it comes to a data, whether you have all the data which is consistent. So when you want to know such kind of information, you go for data distribution to check the normal distribution or log normal distribution. So the distributions are characterized by the parameters that will define their shape. Like additionally the type of the variable, whether it is a continuous variable or a discrete variable. So we have different variables like a continuous variable and discrete variable, which is also another important feature that will define the expected behavior and the values that the variable can take a look into. And after the data distribution, a person should also, data scientist should also know about the central limit theorem. So what is the central limit theorem? What he should know about the central limit theorem? So this central limit theorem is a kind of a powerful rule that will help you to understand the population mean. So population mean is nothing but I have a complete data. So let's say I have a billions of data, billions of data in my hand. I want to know the population mean based on the randomly drawn samples. So from that data, I'm taking a few samples to do the analysis. So randomly drawn samples. So basically, like if you have a variable X and you want to discover the real mean of the variable, so you can record the mean of a smaller samples, and those sample means will have an approximate normal distribution with average similar to the population mean what you have taken. So like this, a neat part you will get it. So this central limit theorem, this rule stands no matter what the underlying population distribution is for. So like for instance, like if the distribution is log normal, you can draw random samples from the variable that the mean of the sample means like will also tend to provide the real population mean value. So for people who are not getting to understand what is this random sample or population, so we have also done another session. I have also done another session on the population and the sampling methods with the help of statistics. You can go take a look at that particular video. So when it comes to the other central for the central limit theorem to hold, there are some assumptions that one must take into account when drawing the samples from the population. So when I say population is nothing but the complete data. When I say sample, from that data I am taking a few sample to check for the variable and check for the analysis. So samples must be drawn from the population. So if you draw a biased sample, for example, only a filtered portion based on the variable, so the central limit theorem does not hold for the entire population, right? So like we have this concept of n is greater or less than greater or equal to 30. So if you are sure that the underlying data distribution is normal, when you find out with the data distribution, you are confirmed that your data distribution is normal, you can use the less data, so the samples are independent to you. So that is how you do this. You go and learn with the central limit theorem. So we are just briefing out the things here. And another statistical concept which you should know is about the correlation and causation. So what is this correlation and causation about? What does this correlation and causation about? We are going to check what is the correlation between the sample. Okay, what is the cause? For example, if you work in an industry, so you have probably heard this a million times, like understanding the statement is like fundamental for a data scientist. So whenever a problem statement is given, you should understand it when it comes as a data scientist. So in an age where finding the correlation is at a very distance of a couple of lines of code, with the help of couple of lines of code, I can find out the correlation. So but understanding the impact of saying that something causes or something else is even more important when it comes to that point. That is very important, right? Sure, for some projects that's not an issue, but most of the times when you are in a data project, there is a need to know why these phenomenon are corrected. Okay, why this phenomenon has occurred, why these phenomenons are connected, not only how they are connected. Okay, it's not like you should only know how they are connected, you should also have to know why they are connected, why these kind of relation is there. So sure, for like when it comes to the data science projects, you really need to understand what your users are looking for. Okay, what your user, you're a vendor or a client, is looking for. Will the effect of the variable on the outcome be used in some way? Like for instance, like if you are building a churn model, okay, we have a churn model, and you find that a positive correlation is there between a company which is calling the customer and the customer's churning exist. Okay, so does it mean that the company should stop calling the customer and they will not churn anymore? Like, no, right? So by digging a bit more into the data, okay, by going in depth and learn more about with the help of the statistics in the data, so like you will get the third variable that will explain this behavior, what you are looking for, why this connection has happened. So the company the company was calling the customers because they had some issue with their service in the first place, and this was the reason why they were churning. Okay, this was the reason why they were churning. So to ensure the causality, like what is the problem, what is the cause, one has to perform some type of controlled A by B test or use other statistical tests. So the observational studies are not only important, okay, is not enough. They don't guarantee the exchangeability. So you will always have to go and check with the correlation and the causation of that particular data. And then the next concept which I am going to share is the central tendency and dispersion. So when it comes to central tendency and dispersion, like for example, we have two variables may have exactly the same mean but different in the range of their values. They have the same mean value, Okay, they have the same mean value, but what is happening in the range of the values what they have got is different. So understanding this is a key to understand whether the sampling and the comparing how two samples differ from one another. Because their mean is same, it doesn't become the complete values are also going to be same, right? So the central tendency and the dispersion are like the two extremely important characteristics of the data distribution. Like the central tendency can be measured with different metrics, like I can measure it with the help of mean, median, or mode, and the dispersion can be measured by the standard deviation or variance. Okay, standard deviation or variance. So by getting to know these by getting to know like these two, dispersion and the central tendency parameters and the distribution type, you will be able to partially visualize the shape of the distribution. You can partially try to understand with the help of the mean, median, standard deviation, variance. You can try to partially able to visualize what is the type of the distribution, whether it is normal distribution or any uniform distribution. You can able to visualize, and how the random variables flows around its expected values can also be seen in there. So discovering these two arguments will be a kind of a very important to understand how one expects a random variable to behave in the future. Whenever I have a random variable, how it is going to behave in the future, I can try to predict, like particularly when it comes to comparing between the samples and understand how similar the data is. For example, in the context like data science, like understanding the central tendency and dispersion will help you to work around the expected values, and it can also help you to create some robust outlier detection techniques. You can also check the outliers, which is not where the data which is not having a which is out of the box. Outlier data also can also be found out. So that is the central tendency and dispersion. And the last one which we are going to see is nothing but the p-value. So this p-values, what is this p-value? So a p-value it will come under the hypothesis concept. So a p-value is a probability that we have ordered, that we have observed, so that a certain value in a statistical test given will tell that the null hypothesis is true. Okay, so for instance, in a regression models, like each coefficient has a p-value which is attached to it. Why? Because that p-value is being used to test the hypothesis that the coefficient effect is going to be 0. So if you have a low p-value, for instance you have 0.01 attached to the coefficient, then you are stating that the probability that the coefficient is 0, or you can say it has an effect on the outcome, which is around 1% a very low chance. So the p-values are pretty important to understand the statistical hypothesis test, and it can be able to use to summarize in a sentence, like how likely would I be looking at this p-value, so that if my null hypothesis was true, on the statistical test you normally aim for low p-values that rejects your null hypothesis. So for this you will have to get a good knowledge on the hypothesis concept, and why hypothesis is also very important for the statistics. So one important thing is that the p-value is tied to the testing the things about the null hypothesis. So the p-value does not imply the validity about the alternative hypothesis. So when I want to understand the p-values, you will be able to understand when the building outlier detection is there. You should also know what is the regression models, hypothesis test, building the features based on the data distribution, the correlation and everything. So all these things you will have to go and try to understand before you start concentrating on the statistical concepts. Okay, so these are all the things which I wanted to inform you all. Though it was very short, it might be very informative to you all, so that in case even if you haven't got the proper information, you should be familiar about the very important concepts which is there. You should know, so that your future will be good in through the journey of the data science or a data analysis. Okay, so that's all from my end. Thank you so much. for patiently sitting and listening to the session, and with a good topic in the upcoming session. I will meet you all again. Okay, until then, bye everyone. Have a good day ahead.